So let's take a look at an interesting equation that you can use logs to solve. But at first, you look at it, you might think, uh-oh, I'm in a little bit of trouble here. Okay, so here we are. What I'd like to do is, I'd like it to look like this at some point. I would love it if this equation looked like a to the x equals b. The reason I like that is because I know how to deal with this equation. I could take the log of both sides, log of a to the x equals the log of b, and then I could bring the x down in front. I get x equals log x log a equals log b, which just means that x equals the log of b over the log of a. And that's a very popular way to solve equations all through Algebra 2, right? And your basic course when exponential functions, you do that. All right. The problem is this new equation has an x power on both sides. So what I'm going to try and do is get everything that is to the x power on, say, the left, everything that's not to the x power on the right. So I'm going to divide both sides by 4 to start, and I get 1.17 to the x equals 7/4 times 1.088 to the x. Okay? All right, not quite done yet. So I'm going to take both sides now and divide by that. Okay. So what do we end up with? 1.171 to the x over 1.088 to the x equals 7/4. All right. I'm getting there. I'm not going to say it looks quite like this yet. And the problem I have is that on the left side, I don't have a single number to the x power. On this left side of the equation, I have something to the x divided by something to the x. So now I need you to go back into your mathematical past for a moment and remind you of something. Ready? Here we go. So a long time ago, you learned how to do things like this, like 3/4 squared. Okay? And you knew that 3/4 squared meant 3/4 times 3/4. And maybe in some shortcut, you started to do things like this. You started writing, hey, that's really 3 squared over 4 squared. Right? And actually, that works for any power. If it had been 3/4 to the x power, you would just do 3 to the x power on top and 4 to the x power on the bottom and get an answer. And you'd be fine. Well, most of your mathematical lives, you've been going that direction. But you're allowed to go backwards. That's what an equal sign means. Okay? Sometimes called a symmetric relation. It means you can go either direction with that relationship. So, here you go. I'm going to use that idea here and rewrite the left side of the equation. 1.171 over 1.088 all to the x power equals 7/4. And there you go. Now this thing is of the form we wanted it to be in. All right, so let's finish off. We'll take the log of both sides. So the log of 1.171 over 1.088 to the x power, that thing, is equal to the log of 7/4. All right, bring the x out in front and divide. So you can see that this x would come out in front, and then we divide by the log of 1.171 over 1.088. We end up getting that x equals the log of 7/4 over the log of 1.171 over 1.088. And that's some kind of number. You leave it like this, it's okay, because that is the exact answer. Right? Now, let me impress upon you a couple of things. There's lots of ways to express this answer. So whenever I give this question to students, I get back answers, which at first I'm like, wait, that looks different. But if I just carefully inspect things, you'll notice. So for example, could have been written this way. Log of 7 minus log of 4 over the log of 1.171 minus the log of 1.088. And if you think about that, that's really the second rule of logs, right? The log of a divided by b, if this is acting like a and that's acting like b, then this equals the log of a minus the log of b. You can do that, right? And if you really want to have fun, we used change of base formula yesterday, so you could write this the following way. Log base 1.171 over 1.088 of 7/4. I'm not going to say that that's the prettiest way to write it, but that's what change of base formula does. Now you might say, hey, wait, review change of base formula for a minute. Well, change of base formula says that if you have log base A of B, that's the same thing as the log of B over the log of A. So what I just did is I used that rule backwards. I went this direction. Look, there's the log of A. This thing on the bottom is acting like log of A, and this thing on the top is acting like log of B. So here we are. We got log base A of B.